In this video, we will be talking about rules of exponents. You should be able to use these notes to help yourself with the first two assignments homework. On your notes, I suggest making 3 columns, one for name, one for rule, and then a third column for example. Each one of these will be about a third of your page. The first rule of exponents we will discuss is called the product rule. The product rule states if you have some number x to some power a, and you multiply that by the same number x to a power of b, then the product is the answer to a multiplication problem, is x to the power of a plus b. An example of the product rule: if you have x to the third times x to the fourth, that's going to equal x to the 7th power. Alright, now over here in the margin, I'm going to see if I can explain why this part in the margin is not for your notes. Just think about it, what I'm saying over here. I'm going to see if I can explain why this is the case. When we have x to the third times x to the fourth, what are we saying? Well, x to the third, when we say anything to a power, we're saying that thing times itself that many times. So x to the third, it's really 3x's multiplied together. Literally 3x's multiplied together. Well, x to the fourth, it's 4x's multiplied together. So what we see here, we don't even need these parentheses anymore. I could drop them. What we have is 7x's multiplied together, and 7x's multiplied together is x to the 7th. All right. So this is just telling us about repeated multiplication, and this is a repeated multiplication. So we have 7 multiplications. 7 multiplications of x's, we can write it as x to the 7th. So while we are multiplying, the shortcut is to simply add these exponents. All right, our next rule will be the quotient rule. Quotient rule. Well, product is the answer to a multiplication problem. Quotient is the answer to a division. The quotient rule says if you have m to some power a and you divide by that same number m to some power b, now you're going to subtract. When we're multiplying, we add exponents. When we divide, we subtract exponents. That makes sense to me. A minus b. Let's look at a concrete example of that. Let's say we have m to the power of 5, and we divide by m squared. Well, that's going to be m to the third. Why is that? Let's see if we can take a look. Well, if I have m to the 5 divided by m squared, m to the 5, that's 5 m's multiplied together. M times m times m times m times m. M squared is 2 m's multiplied together. And you know when we divide, we can essentially cancel factors. M divides with m, leaving 1. M divides by m, leaving another 1. So we have 1 down here essentially. So what do we have remaining? We have 3 m's multiplied together. That's m to the third. So this quotient rule is just a simple way to show the cancellation of our terms. All right. Next is the power rule. The power rule states that if we have some number, say smiley face, and we raise that to some power, say a, and then we take that to the b, this is a power to a power, it's a bigger deal. This becomes smiley face to the a times b. I could put a little dot in here, but it's going to connect because in algebra connected means multiplied. This is smiley face to the ab. All right, for example, if I have smiley face to the third and I square that, that is equal to smiley face to the sixth. And here I use smiley face. It's just a symbol, just like m. All right, it's a symbol to represent some unknown number. You can use anything that you wanted to use for a variable. All right, why is that? Well, let's see if we can further illustrate that point. So, when I say smiley face to the third, and I square that, when I say square, it means this thing times itself. So another way to say this is simply smiley face to the third times smiley face to the third. To say square means this thing times itself, and here I show, well, using our product rule, since our base number is the same, we simply add together our exponents. Smiley face to the sixth. So this power rule is simply an extension of the product rule, much like multiplication is an extension of addition. Okay. Next, we have what is called our negative exponent rule. Negative exponent rule. All right. If we have anything at all to a negative power, x to the power of negative a, it becomes the reciprocal to that positive power. That is, it becomes 1 over x to the positive a. For example, if you have some number like 5 to the negative 3 power, it simply becomes 1 over 5 to the positive 3 power. And we could further simplify this 5 to the positive 3. 5 to the third is 5 times 5 times 5. That's 125. All right. Why is that? Well, it turns out it's going to be extension of this quotient rule. Let's take a look. Let's go back and look at this example we had here, but let's flip this over. Let's think about if we had m squared divided by m to the fifth. Well, we know that m squared is m times m. We know that m to the fifth is 5 m's multiplied together. Well, 1m cancels with 1m, 1m cancels with another m, leaving us with a 1 in the top. When I say cancel, what we really mean to say is divide to leave 1. M divides m to leave 1. M divides m to leave 1. So what we have is 1 over 3 m's multiplied together. It's m to the third. Well, by our quotient rule, it says we're supposed to subtract these. What is 2 minus 5? That's negative 3. So here you see m to the negative 3. It must be equal to 1 over m to the third. This makes sense if you look at it. Here we had 2 in the top and 5 in the bottom. If we did cancellation, wouldn't we'd be left with 3 in the bottom? But we have to make this rule consistent. This rule says if we're dividing, we're going to subtract them. If we subtract these, 2 minus 5, we must get minus 3. So it has to be that something to a negative power is 1 over that thing to the positive power. All right. Lastly, the zero exponent. This rule says anything to the power of 0 is equal to 1. Any number at all, as long as it's not 0. In all these cases, the denominator cannot be 0. That's sort of a a default thing in math. We can't divide by 0, so I couldn't have m equaling 0 in this case. I could not have x being 0 in this case, and I could not have a being 0. 0 to the 0 is not 1 because it all deals with division by 0. Okay, we cannot divide by 0. It breaks mathematics. All right. So a specific example of this would be, say, 7 to the 0. Okay, any number here to the 0 equals 1. Why is that? Well, again, it has to do with our making our power rule make sense. Let's consider this for a second. What is 7 divided by 7? Well, anything divided by itself is 1, isn't it? But 7 we can certainly write as 7 to the first power. 7 to the first power. Well, our rule says if the base number is the same, we simply subtract the exponents. So this must be here 7 to the 0. Since anything divided by itself is 1, we know this thing would have to have the same exponent, and if we subtract some same number by itself, we're going to get 0. So since a thing divided by itself is 1, then something to the 0 must be 1 by our quotient rule. So this 0 exponent is simply an extension of the quotient rule. That concludes these notes. You should now be able to work the first 2 assignments from XYZ homework. Remember that embedded in those problems are examples, student worked examples to help you along.